G'day guys, Mr. Bennett here again. Today we're going to be looking at question 11 on page 32. In this scenario we have a cannonball which is fired out of a 4-metre cannon at an angle of 35 degrees. Alright, so the first thing, this is one of these questions where it's a little bit different from just the normal standard sort of question. The first thing that we need to know really is what height is the cannon launched from up here. Alright, that position up there. So if we think of some basic trigonometry, we could work out what this SV height is by using the hypotenuse in the opposite side. So we'd be using sine. So sine of 35 gives you the height of our particular launch height to be 2.9 metres. Alright, 2.29 metres. So that's the first thing. Now you wouldn't have seen that before, and that's the sort of different sort of things that you might come across when you're doing questions. Alright, so the next part of the question, it says find the time of flight. Now it actually hasn't asked you to work out your initial vertical and horizontal components, but you have to do that if you're going to work out your time of flight. So again, to work out a vertical component, we're using our velocity, which is 300 meters per second at 35 degrees, and that will give you the vertical velocity of 172.1 meters per second. And obviously doing the same thing, you could work out your vertical or your horizontal velocity. Okay, so you should be pretty used to doing that sort of process by now. We look at that as being quite easy marks in a test. Now, to work out how far it's actually travelled, what the time of flight, we know that its displacement from where it's launched to where it hits the ground is going to be negative 2.29 meters. Okay, we know the vertical velocity is in fact 172.1, and we know half of gravity is negative 4.9. Now, when we rearrange this, when that goes across the other side, that becomes plus. So you see there it becomes plus 2.29. We solve that using our graphics calculator, and we get an answer of 35.14 seconds. Okay, so that's the first part of the question, which we found the time of flight. The next bit, it's asking us what velocity is it going to hit the ground with. Alright, so again, it's one of those things. The horizontal velocity stays constant at 245.7. The vertical velocity is going to change. So it's originally going up at 172.1. It's in the air for 35 seconds, and it's having gravity acting on it that whole time. So that will mean that the vertical velocity on the way down is actually going to be negative 172.3. So again, we put that using Pythagoras into the square root, and that will give us a particular answer of 300 meters a second. We again also work out the angle because it's velocity. It will be the vertical velocity over the horizontal velocity, and it's 35 degrees below. Alright, so again we're seeing the same sort of steps over and over and over again. Alright, pretty important. Now to work out how far this is going to travel, it's going to be the horizontal velocity of 245.7 times the time of flight, and that's going to give you, say, 8,600 meters. So let's say it's 8.6 kilometers. Okay, you can round these things off if you need to. It's the process that's more important than necessarily the answer. What's the kinetic energy of the shell when it hits the ground? Well, that's going to be a half of its mass. Well, it's got a 20 kilogram mass. Okay, it's travelling with a speed of 300 meters per second. So it's going to hit the ground with 900,000 joules or 0.9 megajoules. Alright, it's depending on how so probably best to show that you can work scientifically and use scientific notation. Alright, so that's probably the best way to represent your answer there. So I want you to get used to doing that. It's really important to do that. Now, obviously the acceleration of the shell. Now we know that this thing accelerates over a distance of 4 meters, and its initial velocity when it's being fired is 0. Its final velocity when it exits the barrel is going to be 300, and it's got 4 meters to accelerate. So if you're just using the acceleration formula, which we did in year 11, Right, you've got a few options there, but this one probably gives you the right one because we've got the distance in there. So 2as equals v squared take v0 squared. That gives you an acceleration of that. Alright, so that's a little bit different. You've never seen something like that before. We assume knowledge, all the stuff that we did in year 11, that you would be able to do that. Again, you know, over here in red, that's just showing you some of the formulas that you have available to you that we did learn about last year. Remembering they're all on your particular formula sheet. Now, to work out the time it's going to take to exit, right? So obviously the time's equal to the change in the velocity over the acceleration. So it's going from 0 to 300 over that acceleration period. So it's going to be 0.02 seconds time to actually go through. Now, if we think about what power is a change in the energy over the change in the time. Okay, change in the energy over the change in the time. So we know the energy changed is 900,000 joules over 0.02 seconds. So that there means that the power that the rockets or the cannons actually exerting is 3.3 by 10 to the 7 joules per second, which is what we're looking at. So that's question 11. Right, quite a different question. Again, it comes through that you need to be flexible with the way you solve problems. Right? It's not always going to be exactly the same every time. You've got to use the information that they give you to actually answer the question they're asking. Alright, so you need to have that flexibility to do those sort of things when you're doing these questions. So good luck with doing some of the others.